Okay, question 5a. The particle model can be used to explain the properties of gases. Describe the direction of motion of the particles in a gas. 1 mark. It's a really sneaky question. Lots of people will say, very fast or anything else. It has to be the direction. So the key bit there is a random direction. Explain why heating a gas increases the average speed of the gas particles. 3 marks. 1, 2, 3. So remember, explain is a describe plus, so what happens. So when you heat the gas, heating a gas increases its temperature and internal energy store. Okay, key bit there is the internal energy store as well. We know that internal energy is made of kinetic and potential. Gosh, I've lost my train of thought then totally. And potential energy. We also know that kinetic is proportional to temperature. So when we say the temperature of a gas, we're actually making a comment as to how fast the particles are travelling. So something that's very hot, temperature is a measure of the average kinetic energy in a gas. So if kinetic increases, if kinetic store increases, speed of particles increases. Okay. Water can exist as either a liquid or a gas at 100 degrees Celsius. Explain why a mass of gaseous water at 100 degrees Celsius contains more energy than an equal mass of liquid water at 100 degrees Celsius. Okay, so why does gas water have more energy than liquid water? It's worth 2 marks, so 1 and 2. So we're going to say, first of all, what happens? Well, what's the difference in terms of the liquid and the gas, even at the same temperature? So energy is needed to break bonds between particles in a liquid to form a gas. Okay, so energy is needed to break bonds between the particles in a liquid form gas. We know that's called latent heat of vaporization in this case. So it's the latent heat. So this energy is stored in potential store of gas. Okay, you can also, if you want to, you can also call it, we call it latent. In fact, in this case, we can use the correct term. We call it the latent heat of vaporization.